Hello everybody! Today I would like to tell you about a very interesting project that covers not only software, but even hardware. The junctions of different technologies and directions, the FGX Native mobile development tool, Arduino, microcontrollers, addressable LED stripes, and of course our favorite programming language Delphi. This nuclear cocktail will be discussed today. Few words about me. My name is Yaroslav Brovin. I am a FireMonkey developer for 30 years, including as part of the Embarcadero team. I am a founder of FGX Native library, which is designed for development fast native mobile application for Android and iOS. So, today we will begin from take a look at the smart LED backpack and see the final result. In the first part, we will look at how to make the hardware of a smart device. We will make a smart backpack out of electronic components. We will find out what components we need, the connection diagram, and how to install the firmware on the microcontroller. In the second part, we will make a working prototype of mobile application that will allow us to manage our backpack. This application will be developed with Delphi and FGX Native. We also will have a look at the protocol of communication with the hardware device. We will see how to organize navigation between mobile screen in mobile application and how to make it easy and customizable. And in addition, we will touch on the issue of UI relationships with model data using the example of Google LiveData. Finally, we will use Material Design 3.0 for design of our FGX Native mobile application. In front of us is a LED panel that is fixed on the back of the backpack and a mobile application developed in Delphi and FGX Native. When loading, the LED panel automatically turns on the last mode in which it worked. To control the panel, we need to connect via Wi-Fi to the device. To do this, we click on the Connect button on the header. Android searches the network of our device, and after it finds it, it offers to connect via Apply and Connect. The button indicator turns green and we see a toast confirmation message that the connection to the panel has been established. On the main screen we have a dashboard from which you can quickly turn on various modes such as enabling the demo mode, displaying the clock on top of the panel, weather display, running a text line, and in addition you can launch your favorite effects or launch the panel in game mode. Let's turn on the demo mode. Now the panel displays effect in an arbitrary way at a fixed time interval. Let's switch to the All Effects page. All the effects are grouped here. From the top row you can select a group, while the list of effects is dynamically rearranged with animation. For example, space category, noise, weather, house, image, game, abstract, nature, and etc. Let's switch on the effects and observe them. When we tap on any effect, for example on matrix, the application opens the screen with the effect. From the same screen we can quickly switch between effects. Let's apply the matrix and tap on matrix button. Let's swipe over the all available effects madness noise, for example, cloud, lava, rainbow. It's really beautiful and amazing view. Additionally, we can edit the specific parameters for each effect. For this, we should tap on the Settings button. Application shows Settings page, and there we can change contrast and effect speed. The following page and mode of this panel is Games. The panel supports several games like Tetris, Maze, Arkanoid, and Snake. Let's try to play in one of these games. For example, Maze. The panel loaded Maze, and we can control by dot via special controls buttons on the screen. After finishing level, panel shows next level, Maze. We can also switch and show running text over the effect. And we can see the text line, hello from FGX Native. You can send any text line and show it. We also can show a clock over the effect. It can be useful for someone who is looking at your backpack panel. Also, application and LED panel support painting, and here we can select any color and draw something. Or just clear. Oops, I closed the application. Also from this page we can upload a predefined image. This application has internally in resources image icon with rocket. Let's load it to panel. We can see how the application loads row line by line a rocket. The last page in this application, it is settings page, where we can change any device settings. It is like a size, because you can create the matrix of different size, not only 16 on 16. You can use, for example, and the lightning of Windows. In this case, you can have a bigger size of matrix. Also, you can select connector type. It is where the first line is located on your matrix. And also you can change the default name and password for access point, Wi-Fi access point, which LED panel is create. And additionally, you can change the weather server, because the panel also can show current temperature and the weather, and it takes from by the internet from different weather services. I hope this application, this demo sample, you will like. We take the project of the famous video blogger Alex Guyver as a basis. You can get acquainted with his project in detail at the links provided. In one of his projects he tells how to make a LED matrix, the nuance of creating hardware, how to use Arduino Studio, and the nuance of using microcontrollers. His project already has a ready-made firmware for the microcontrollers, which we will use in our version. His firmware also provides a web interface for remote device control via Wi-Fi. We just need to connect to the LED panel via Wi-Fi and go to the settings page in the browser. However, we are in favor of native mobile application development. That's why we will write the software part ourselves instead of the web version, and we will use the full power of Delphi and the native API. Let's figure out the hardware part. We will need the following components to build the device. VMSD1 mini microcontroller based on ESP microprocessor. The matrix of address LED, USB power cable, a pair of soldering wires, and a power bank for autonomous power supply. You can buy a ready-made matrix or you can solder it yourself. I choose the second option because in this case I can create a matrix of any size and with a larger distance between the LED. If you would like to make your own matrix, then you will need about 5 meters of LED stripe, soldering wires, and for case you will require a plate of white and transparent plastic and super glue. To begin with, I cut the tape into the required number of LEDs. You can choose any number. I took the length of 16 elements. Then we glue the tapes onto a plastic substrate and solder the pieces of tape with a snake. The tape can be soldered in two ways, zigzag and parallel. In this case, the snake is selected. For more information about the features of soldering and the choice of methods of connection stripes, see the article by Alex Gaive. After that, we make a grid of plastic so the light from each LED is separate and square. At the end, we passed the light scattering plastic. And finally, we have a ready-made matrix made with our hands. We try on our matrix to the backpack to make sure that our sizes match. We check the permeability of the matrix. It is better to do this by completely gluing the case, since mistakes can be made when soldering. Otherwise, we will have to disassemble the matrix and again solder any sockets. Next, we proceed to soldering the simplest connection scheme. There are different ones. They are available at the link below. In our case, this will be enough. We have 3 wires, 2 are power, red is plus and black is ground, and the third, green, is used for data transmission from microcontroller. 3 wires are used to power the matrix and supply the control signal. Separately, we use the USB port to supply power to the circuit. After everything is ready, we need to download the firmware to the microcontroller. All the details and nuance are specified in the external project. Therefore, I will not describe everything in details. First, we download the project from GitHub, install Arduino IDE. After it, we need to install special driver for connection microcontroller board to the computer. After it, we should open project in Arduino IDE, apply basic settings for our devices in special defines in C++ code. For example, we should specify the size of our matrix, connection method, and etc. And finally, we connect the board and flash the microcontroller. Okay, now we will start developing a mobile application with FGX Native and Delphi. But before that, let's get acquainted with FGX Native, which is the main technology in this project. FGX Native has been celebrating 5 years in this year. During this time, we have a large number of clients who have done, are doing, and continue to interesting projects. FGX Native is fully cross-platform standalone framework designed for the development of native fast mobile application. It doesn't depend on FireMonkey and it is completely native as VCL. But unlike VCL, it supports across platforms, iOS and Android. The library offers a large set of ready-made components designed with the specifics of mobile platforms. Modular, expandable, with its own integration and designer in Delphi. FGX Native already supports many external services, and at the same time this list is constantly growing. These are services for payment inside your application, cards with different tile providers, analytics of your application, authentication through various services, embedded advertising, built-in barcode scanner, support for different push notification providers, the ability to get a digital signature from the client, make call, and much more. Among the basic components, it is worth mentioning a set of basic containers, which are designed for different display and grouping of controls. And of course about the support for the Flexbox alignment system, which came to us from the web and the rubber layout of screens. The library also supports right-to-left languages and offers a means to localize your application. In addition, we have a large set of tools and components for working with media data, video, photo, camera, SVG format, Lottie animation, custom form, and etc. Well, FGX Native is also support a dark theme. And much more and more features are available in FGX Native. You can find detailed information on the official website and forum fgxnative.com. Now let's go directly to a practice. Let's start by analyzing the interaction protocol. Two protocols are supported, UDP and MQTT. Although UDP doesn't guarantee the delivery of commands, I choose it because it is easy to use and it doesn't take a lot of time for implementation. The command format is the same for all protocols. The command starts with a $, followed by the command code and a list of arguments. The command must end with semicolon. For example, there are a few samples of commands. The first one, select special effect with ID. The second one, turn on LED device. And the last one, set specified pixel color with specified coordinates X and Y. Now, let's go to the code and have a look at the Delphi implementation. So, in front of us, Delphi 12 IDE, and I loaded a LED panel project into Delphi. The first unit is at ladpanel.api, and it includes description and implementation of all classes for communication with our electronic device via UDP. This unit includes all required classes, and the main one is TLED device client. It provides several methods based on firmware API, and you can, for example, turn on device, turn off, switch power, select game, send key event on the device, for example, for playing in some games on our LED panel. We can change brightness. We also can paint on this device. We can send running text, change effects, change parameters of each effects, works with weather. Also, we can show clock over the content and much more methods. It doesn't include all available MPI methods, just only a subset. But if you would like to expand it, it is not really complicated and you can do it yourself. Since we are using UDP protocol, I choose Indy T UDP client, and the two basis methods send commands. It just sent a string to a client to our device. Since UDP doesn't guarantee delivering our data, we using receiving string method with 1 second timeout, and we also log all calls of communication between our device and our mobile application to device log. If something is not good, we just close connection to device. The second overloaded method send command works with command and set of arguments. Now let's have a look at how, for example, turn on methods was implemented. Based on general templates, we should send sign $, command number, and one it means it's analog of true Boolean value. If you would like to pass some data, for example, this method sets specified pixel with current color, we just pass coordinates of required point on LED panel. As you can see, the implementation of the interaction protocol is very simple and doesn't require any extensive knowledge in this area. So now let's have a look at the code which connect to Wi-Fi. Our device has embedded Wi-Fi adapter. When the device is turning on, it launch access point, Wi-Fi access point, and we from our mobile application should connect to this access point, and after it we can send commands via UDP by special IP address of our LED device. By default, our LED device has the followed IP address and port. The second part, it is of course user can connect to the access point of the device manually via Android or iOS settings. However, it is not convenient, and Android device, for example, provides special manager for automatically connection to required access point directly from application. So let's have a look at this implementation. I created special TFG Wi-Fi manager class. It works directly with Android API, and for working with Wi-Fi we should request Android System Service Wi-Fi Manager, set several listeners, and when we would like to connect, it is just we need to build a special request with access point ID, with password, and request network via this system Android services. If connection was established, in this case we know about it by the special network listener instance. If connection was lost, for example, we also will know about it via special methods on lost. When some state of connection was changed, we just notify clients via event handler about it. In this way, our device client create Wi-Fi manager, specified required handlers, because we would like to know when when device was connected, was disconnected, or in case if some error or was occurred or network was not available for this device. And we, in this handler, we after connection, for example, we connect via indie UDP client. We also store internally new state like TLET status connected, request basic settings, and notify clients of this class about device status changing, again with event handlers. For working with this class in all application, I am using singleton template. So each form or data model can request this client via class property instance. Of course, there are a lot of different way how to inject this instance into special units, but for simplification this demo, I use singleton template. After we have figured out the protocol and the connection to Wi-Fi network, we will now figure out the navigation inside the application. Let's start the analysis of our application with screens. We have divided all the screens into three types. The main screen, it is entry point of application. It is made on the basis of a form. It is displayed in full screen. The second entity, it is fragments. This is a part of the interface that can be embedded into other containers. They are made on the basis of TFG frames. And the last one, it is dialog boxes and pickers. Those are displayed on top of the screen and overlap the content of the main window. Schematically, the connection between the screen and the fragment can be represented as follows. The main screen has a special container in which we embed different fragments depends on current section in bottom navigation panel. How the main navigation works? We use a special TFG pager layout control container for navigation. The pages are fragment, and when user is clicking on the corresponding menu item in the bottom navigation, we switch the active page to the desired one in TFG pager layout. Now let's take a look at these fragments and screens in Delphi. The main form consists of three parts. The first is the top navigation bar. It shows special button for connection to Wi-Fi network. It also have hidden back button in case when we are in the internal detail screen and we would like to move back on the previous one. The second part is a pager layout container, which includes different frames with dashboard, games, paint, effects, settings, and etc. And the bottom navigation, which is based on frame and includes 5 buttons with section in our application. As you may have noticed, this is a special FGX Native form designer, which provides convenient cool features for fast prototyping. For example, we can disable and hide grid for alignment. We can show over layout for visual displaying padding and margins. or we can just hide design border for containers. Also, when we select any component and we would like to try to change position, also designer show position, new position, and the current size of control with the component's name. In Form Designer also you can switch to iOS style and Android, and you can apply some templates for looking how your mobile form will be apparent on the small screen devices, normal or large. For example, on small screen size it will be looked like this: normal and large. As you may have noticed, in this application I am using Material Design 3.0. Despite the fact that FGX Native supports the design of the target operation system, version 3 of the Material Design is not a System 1 on Android. However, in this project I used the manual and made the UI according to the guidelines of Material Design 3.0. In particular, I have developed several components based on the frames. I placed them into Material Design subfolders. For example, track bar in Material Design looks like this. It is just a regular frame with component TFG rectangle as a background and layout with thumb and the small icon on the right side of track. In code, I just provide properties for settings value, some event for which is invoked when value is being changed, and based on touch event, I tracked the moving finger over the component, calculate a new size of track, and calculate a new value. It doesn't look complicated, just several lines for new control, which is designed directly into IDE. I also have implementation of the navigation bar. It is a button. It is a container which can consume buttons. The buttons also is a frame, and it includes special indicator when bottom navigation button is selected. It also has special images with pointing on current theme and title. And it has a small code for updating appearance of this button when user make a tap on this button. Also, in this code, I have use animation. Also, in this code, I use predefined animation templates, and just with this call, I hide with animation and show this indicator when user switch active states of this button. The next component from Material Design which is required in this design is chips. Chips, it is small buttons with text, which is placed with possibility to scroll container, and they can also use icons. It is the same approach as navigation. Chips, this is a frame as a container based on scroll box, horizontal scroll box. It also provides methods for add chips special button with title and image, and each button has active state and only one button can be selected. The chips button looks like this. It also can supports icons, and in this frame it's just a simple button. Also pay attention that we provide predefined different styles of button, and we can use text without border, outlined button style with border, and contain it is button with filled by with color button container. Also it provides different property for each different styles, and you can change and appearance of border, content padding. You can change border corner sizes, thickness, colors, icons, apply it automatically theme for icon. For example, we can select some icon, for example SVG icon with dislike, and also we can apply it tint color for this icon automatically on control level, or we can use original color black, or apply for example red color. It is really easy to set up button settings in IDE, and we provide a lot of different properties and settings for reaching your design. Now let's have a look at the fragments. Now we have special fragments, as we talked before. We have several major screens. It is dashboard, and you can see it includes different cars, lists, and our material design components. The same we have for effects. This fragment shows the list and grid of effects with preview. We also have games frame for playing in game and selecting one of the game in the list. And we have painter. It is special frame for drawing on our LED device directly with specified selected color. We also can download and upload that image to the and from the device. And the special fragment with device settings. For settings, we are using special TFG list menu component. It is special list which support different item style. We can add any count of required items, and we can adjust the appearance of each item. For example, we can select icon, is it selectable item, we can change style just in via style property, and we can change general properties of appearance, for example color from theme, icons, and the color of primary and secondary elements on each item. The dashboard fragment is designed with using different frames. In this case, I also have I introduced a special name widget. It is small composite control based on again frames with some internal business logic, and I embed them into directly the dashboard. It also based on vertical scroll box content, so in case if screen is small, it automatically supports vertical scrolling. If we talk about widget, for example, we have some basic demo widgets. One moment, let's open widget unit. The first, it provides embedded device client, LED device client instance for working and controlling any action directly from widgets. We also provide some templates card with lot animation, some switcher, and title and description. As I mentioned before, FGX Native support Lottie animation. In this case, we just need to put special control Lottie animation and specify animation via special property, for example, snake. After it, this card is used in special widget. For example, clock. Just specify required title and description, sets special animation, and it has internal business logic. So when user change switch, in this case we set current daytime and change via LED client clock over effect. So when user enable it, it will show on the device clock over the current content of a device. If he disable it, it turn off this layer with clocks. The same we have for the demo widget. When user turn on the switch on this widget, we set demo mode. In this case, LED panel will iterate over the all available effects with some interval update. For example, just 10 seconds, for example. The same way the other widgets I designed. But what is about for showing effects with nested horizontal effect? For this case, we are using special collection view controls. It is really powerful container which can show a lot of items. For example, 1000 or several hundreds. It really doesn't it is very fast, and it consumes a very low memory because it has some interesting approaches. But for us, this control doesn't really shows all items in this list. This control also has some style. The style is the entity. It is describe how item will be displayed in this list. Now, this control supports a lot of different counts of styles, so you can add predefined styles, or you can just add new one and put any controls what you would like and create appearance of each items. For example, this one is designed on card panel controls with internal image preview. How it works? The control doesn't store any data in this component, and it just requests some data from your user's model. Let's go to the implementation of this widget. This list provides the two important events. The first one on getItemCount requests how many items you would like to show in this list. In this demo, I have internally create list with effects, with predefined effects, and I just fill it with some effects from constant array. After it, when list would like to show items, it requests items count via this property, and will just return count of items is in this list. The next important and major event is on bind item event. When item is being displayed in this list, the collection view asks our developers about showing users data on this item. For example, for each item, I request effects, extract effects by index. After it, item, it is a special wrapper class which give access to the each control on this style. And for example, I extract TFG image instance with lookup name preview. So let's look at the style. We are using TFG image control, and we have special lookup name preview. So preview image will contains this instance, and after it we just change image name for required effect. We extract ID from effects by index and just specify image with this effect. That's it for it is enough for showing effect list. The same approach we are using in grid for showing all effects. The same as a widget with effects. In this case, we are using vertical orientation, but for dashboard, we are using horizontal scroll orientation. In this fragment, we also use column supports, and we specify 3 columns for this grid. And also we designed special styles with label, title, and image preview for card. And the same approach, get item count, return the count of items in my model. On effect bind, we set title and image to the item controls. We're also using some tap event. When user make a tap on the item, we change screen and navigate to the detail view with selected item effect. Also, I would like to keep aspect ratio of the preview effect image in this list. For doing it, I introduced special methods which update item size with current aspect ratio. So it makes some calculation with accounting margins, paddings, sizes of labels, and etc. And when list is being bind item, we update invokes and use this method for updating item size. So we can dynamically change size of any item. Also, you can, in case if you don't want to use a lot of different items, for example, we have 4 games in our devices, we can use just a regular scroll box with 4 cards about these games preview. It also a special widget is based on again on the frames. Now let's talk about navigation between different screens in application. The idea was borrowed from the Google Jetpack navigation library and implemented as a prototype in the current project. When, for example, you need to show a new screen, you need usually to create an instance of the form, show it, then delete it somehow, organize the transition animation, organize transition history for possibility to go back to the previous screen, and somehow animate this thing. There are usually problems with animating forms in VCL or FireMonkey. Everything would be fine, but the application is not limited to form alone, and as we can see from this project, there are also dynamically changing parts of the form that are embedded into other containers. And that's where it gets even more complicated, because it is necessary not only to create, but also to somehow track this embedding, animate, and so on. The idea of the navigator is to create a graph of possible transition between forms, fragments, and dialogues. The vertices of the graph are fragments and forms, and dialogues, and edges are actions that describe the transition from one UI element to another. In this case, the action also describes which animation should be applied during the transition. And you can see such graph for our application on this slide. The arrows indicate transitions from different UI elements to other screens. I made a quick implementation of the navigator. We register fragments, forms, and dialogues at the start of the application. For each element, it describes the connection of transition and additionally, if necessary, specifies the type of animation. In this sample, we register our key elements in the navigator. It is dashboard, effects, settings, global settings, effect settings, and some kind of dialogues. We specify a relationship for each element, where we optionally specified the type of animation for the transition in the forward direction. For example, if you would like to move and open effect screen from effects master fragment, we add this action from current to dialog effect settings and show transition effect. So we will show this dialog screen as model form, and when user will press back button, we will use model hide animation for hiding dialog effect settings fragment. With this approach, we encapsulate the animation of transition between screens, and also it allowed us to hide different screen implementation. For example, if you want to use different version of the mobile, different version of screen for mobile and tablet devices, we can use this manager to change the implementation of the opening parameters and fragments on the fly. So now let's see how we can make transition by clicking on the button, for example, from fragment effects, and open a special window for one effect selected. When user make a tap on some item, we ask T-Navigator perform transferring from current screen to fragment effect. Before it, I remind, we register fragment effect and this action in T-Navigator. Optionally, we can pass some data to the target fragment. For example, for opening detail view of selected effect, we should know effect ID. So we pass dictionary as key, it is name of parameter effect index, and the second value, it is a value of this argument. So when navigator controller will perform navigate, it will dynamically allocate T-fragment effect, embed into self container with specified animation, and inject effect ID into property with special attribute. If you open effect, we see property effect index with special attribute input, and when navigator will show our finally fragment, it will inject existing fragment ID into such property. If you when user User also can open effect settings from this screen, and we use the same technique in this place. When user tap settings button, we perform navigation from current view to dialog form dialog effect settings. We also inject and pass effect ID property and pass it to this dialog. If the name of attribute is the same as property, so we can don't specify argument name. So we can modify our demo sample as I did. Now let's see how this transition works on the device. Open the list of effects and select the effect. After that, a secondary window opens with animation with a preview of the selected effects. When we click on the settings button, we go to the model form with effect. The last thing I would like to show you is the technique of using LiveData. It often happens that data can be displayed in different places and in different views. In our case, we need to display the actual connection status to the device. For this purpose, we have a button with a color indicator on the main form. There are several different ways to do this. The easiest way is to use just a regular timer and periodically request the connection status and display it. But constant pulling requests loads the system with unnecessary checks. Another way is to notify the UI of changes in the data model. It is this method that is used at the heart of the so-called LiveData. The idea is also borrowed from the Google Jetpack library. The observer template is used as a basis. The unit which explain how LiveData works is arc.livedata. TLiveData is a base class in this technique. It is a container for the value. It also keep and monitoring the version of storing value, and also it allows and provides functionality for observing about changes data in this instance. So now let's have a look how we can use it for our task. The first, in our API client, we introduce a field for storing status, and we called it a live status. It hold value TLED status. Disconnected, connecting, connected, and device was not found. When connection is established, we just set new status for this field, connected. When connection is failed, we set status disconnected. And if device was not found in Wi-Fi network, we set a related value. In main form, we are using interface, special interface iObserver, what was introduced in TLiveData. It is a base interface, and each observer who would like to observe over the value in TLiveData has to implement this interface. So we do it in T4 main level. After it, when value of status is changing, we just update our UI interface. change indicator color, and show small toast message in the bottom of the screen. Before it, when we request status, we have to subscribe on observation, and we use just this line. So if we would like to track this live status in other places, we just use a single access to live status property in our device client and just add new observer to list over this value. The other sample of using this technique is a settings fragment. We have a special fragment with settings. Also the same let device client storing settings in LiveData wrapper, and if some values are changed in the settings, all subscribers will be notified about these changes. So we use the same approach here. We introduce and implement interface of observer with instance of LED settings. We are making subscription in constructor and unsubscription in destructor. When value is being changed, we just update values of all settings in a special component. Each item has a special property description which is designed for showing the second text line. Now let's have a look about changing this value in runtime. When user make a tap on one of the line of settings, for example, he would like to change size of matrix, he is making tap. And for example, if the current item is matrix size or matrix height, we are requesting and using navigation controller for navigate to dialog matrix size, this one. And when value is being changed here, we update value in live settings size property. And in this case, LiveData will notify all subscribers. At this moment it is the fragment settings about changes, and we automatically update UI on this fragment. At the end, I would like to introduce you to our subscription. Our subscription is valid for 1 year and gives full access to the technical forum, discussion, examples, articles, and etc. You also get a year of technical support on forum. After expiration of your subscription period, you can continue to use all versions of FGX Native received during the validity of your subscription. Subscription renewal is carried out with a large discount of more than 16%, but this price is valid only if you have an active subscription. In honor of the current event, we would like to provide a good discount on the subscription, and with the coupon code SUMMER 2024 you can purchase it for just few and $99. Thank you for your attention, and if you have any question, I will be happy to answer them.
Well, great demo. I've seen Yaroslav do demos before, and it's not just the quality of his components and the clarity of how he describes things, but the beauty of the actual apps themselves that he creates just as demos. It's amazing. And I'm pleased to say he's joining us live in the studio now. Hi, Yaroslav.
Hello.
Hi. Excellent. Really great demo. So I did pin some questions and comments because some people asked some questions. Patrick, who you know who Patrick is, very impressed with your LED Tetris backpack, was how he said. Oh, and you have it behind you as well. How brilliant!
Yeah.
Yeah, that's great. This is the kind of demo that Jim McKeith would absolutely love, because you know what he's like. He put his brain interfaces on and things like that. But yeah. So just one thing that I wanted to make clear: FGX Native, which people can get to if they scan your website, that is a set of components, and it basically is like an alternative to FireMonkey. Is that fair to say that? Is that a better way of saying it?
Yes, FGX Native, like VCL or FireMonkey, is independent framework with independent basis, with independent designer. But opposite FireMonkey, it uses another idea, like in VCL, because in FGX Native, each control is based on native view. If you talk about mobile platforms.
So I thought it was quite important to emphasize that, because sometimes I think people don't realize, they look at the screens and they see a designer and it's so well done that I think people just think it's part of the IDE, which actually might mean it isn't part of the IDE because it's so well done. But it's your work is just so polished and so professional, honestly. Even when you showed the diagrams of the screens, the whole thing was real masterclass in connecting up hardware, which, as you said, you got from somewhere else, but also designing an application, a mobile application, in a really great way. And the fact that you've got fragments, which are like frames, I suppose that's probably a good analogy, but all the things that you tied together is really, really good. Yeah, so Conrad Vermeulen, who is MVP from the UK, he said, what brand of LED panel are you using? You did answer this, but
yes, I built it myself because I would like to take it myself. So I bought just a address LED stripe, just a microcontroller and few wire ways. So in general, I think I spent about $20 maybe, and it can be cheaper if you, for example, make an order for in AliExpress, for example. But also this project can be used for curtains for Windows for New Year's, and I have also a stripe for it, and I hope I will do it for this winter too. But it is not my idea, of course. It is just based on.
No. I mean, you're showing your software, but this is just a way of emphasizing. But I thought it was interesting that you said you actually did it as a present for your son, which you must be the coolest dad ever. I'm sure he was very pleased with you. Yeah, and as you said, you thought the total price of the app was the hardware was about $20. Somebody asked if the app was available in the App Store, and you said no. Actually, it's just a demo app. It's it's not really there. A couple of other things as well. I mean, they're kind of focusing on the project, so they've missed the point of what you were talking about, which is the components, the FGX native components. But as you said, the project has the ability to control the panel via the web protocol in the browser. But you're a Delphi developer, so you wanted to, you're interested to show beautiful native application, which it is. This session that you just showed, it will get shown again. I mean, we split all of them up and show them, but it's one where I think I would also show it for people who want to understand how to write mobile apps, because I think FGX Native definitely has a place there in people's minds about, well, I could do it with FireMonkey, but I could also use FGX Native because they're absolute gorgeous. I mean, the controls, they're all native controls. Is that right? They show up natively on Android. Is that right? Or are you,
of course, there are different
doing own a draw type? Oh, I think your internet dropped out a bit there.
Features with animation, custom
animation
with
breaking up a bit.
This functionality because we're focusing on speed, performance, and just a limited animation kind. But from other side, FGX Native provide a good performance for application, and it looks like a native application, and it works like a native application. But in FireMonkey side, you have a more possibility to implement your ideas into real life.
Yeah. Well, I mean, it's just like, TMS Web Core and IntraWeb and Uni, some people like one, some people like another, some people like another. And I think it's important to have choice. And Embarcadero, you're a tech partner, so, and a MVP. So, my job is to show what can be done with Rad Studio and Delphi and not really to pick sides. And I think your components are really well written. I think the quality is excellent. The price is, certainly for Europe and the United States, is actually very, very reasonable. And I noticed you said as well you're doing a special offer as well. So for this, great stuff. The Einstein 8854, who's they're always here. They've been here all 2 weeks. Said interesting, but need time to digest the information. Idea and solution. I need to review it in quiet time. Well, there will be a replay, and you will get to see this again. And of course, you can replay the whole day's events. But Yaroslav's video will be being played again, probably starting next week. We're going to start doing the individual sessions and promoting them. But great demo, Yaroslav. I really enjoyed it. Okay, all right. Well, we're going to call it a day now because we need to catch up some time. But thank you for joining us, and thank you for a really great demo. And your components are gorgeous. I really love them. So well done.
Thank you for this great event. It is really important for Delphi world.
Yeah, well, I'm a Delphi developer myself, and I think it's important to make sure that people realize that it's a thriving language and the things you can do with it, like really good mobile apps and an LED backpack, which is awesome. As soon as I saw the title, I went, I can't wait to see that one. Yeah, brilliant. All right, well, thanks a lot. We'll see you soon.
Thank you.